So, hello from me today again. So, today we're going to work out the chapter 3, which is fractions. So, when we look at this chapter, fractions, it's like really, really important because this is one chapter that which is done only in grade 10, but it carries a 10-mark question for the O level paper itself or in the O level paper itself. So this is one important section. Like if you get a thorough understanding of this lesson, you will get like you have a confirmed 10 mark in the paper itself. All right. So let's see, I'm going to start off with the basics of fractions itself because I understand like a lot of children struggle with fractions in understanding what's an equivalent fraction, how do we apply this, what types of fractions do we have. So I'll just take you through the review exercise first, and then we will actually look into the questions like how do we apply these question I mean apply fractions to these questions. So I tell all my students the basic, the fraction question can be done if you really understand the question clearly. So the most important part is to understand what are they trying to tell. So we will look into the questions, at the latter part of this video. But for the first part, like we have to understand what are the types of fractions. So we have unit fractions, proper fractions, and improper fractions. So the first thing that you have to know is like the number at the top is called the numerator and the number at the bottom is called the denominator. Unit fractions is when you are taking 1, right? So let's say 1 over 7 is a unit fraction because we're taking 1 out of 7. And proper fraction is when the numerator, when the number at the top is smaller than the number at the bottom, than the denominator. Like for example 7 over 8, it's a proper fraction. But if I talk about improper fractions, it's when the number at the top or the numerator is larger than the denominator. Like 6 over 5, because 6 is larger than 5. So numerator is bigger than the denominator. Right, so that's about proper and improper fractions and unit fractions. And next comes like how are these improper fractions formed. So improper fractions, or they come with mixed numbers. Like for example, if you look at this one, 2.5, right, you can take this as 2 whole circles. Like you have, for example, we can tell like I have 2 pizzas or 3 pizzas where I eat 2.5 of them. So 2 whole and then I eat only half. So this is my pizza that I'm going to show. Now if I want to show this as an improper fraction, right, you've got to understand that I'm going to divide all 3 pizzas into halves. So now how many halves do I have in total? Like 1, 2, 3, 4, 5 and 6, right? I have 6 halves there, but I ate 5 halves there, 5 out of the denominator 2, so 5 halves. So when I ate 5 halves, so basically when you're multiplying, it's 5 over 2. So as an improper fraction, you can say 5 over 2, right? But that's like the conceptual understanding using the diagrams itself. And if you want to know the calculational method or an easy method to do this question, what you're going to do is you're going to multiply the whole number by the denominator. 2 times 2, which gives you 4. And then you add the numerator, which is 5. So 4 plus 1 is 5 over 2. So that's how we get that answer. That's how we convert mixed numbers to improper fractions. All right, so we multiply the whole number by the denominator and we add the numerator. Remember, the denominator does not change. It's always the same. If it is 2, my denominator in my answer is also 2. So next, let's see how to convert an improper fraction to a mixed number. The same thing if I have to look at the diagram and say I ate 2 wholes. This entire wholes I've eaten. So I've eaten 2 wholes and from this I've eaten a half. So I can say 2.5. But looking into the computational method that we can apply over here is dividing the numerator by the denominator. So I'm going to basically divide 22 by 5. So I'm just going to quickly draw this division bar here. And 22 divided by 5. So how many 5s go into 22? 5 times 4 gives me 20. So it's 4 here and a remainder of 2 there. So what happens over here now is the whole number becomes the quotient, or the value that we just found here. This is my whole number. This will be my numerator and my denominator will remain same. So my final answer would be 4 wholes and 2 over 5. So let's put the fraction bar again. So 4 whole and 2 over 5. If you want to check your answer, you can redo, like, you can convert the mixed number to an improper fraction and check it out. So 4 times 5 is 20, 20 plus 2 is 22. So you get 22 over 5. This is like the simple thing about fractions. But we need to know this to, move to the difficult part, or not exactly difficult, but maybe a little bit higher parts of it. So yeah. Moving to question 3 there, what have they asked us to do? Fill in the blanks. This is basically they've asked us to find equivalent fractions. So if we talk about the conceptual understanding, once again, there are different ways that we can work with equivalent fractions. I'm going to show you a simple example once again. Let's say I have a pizza and 2 diagrams shown. They are equal in size. Let me just draw them a little bit again. So yeah, something around this line. Let's say that they're both equal, and then now I'm going to divide this first part into 2 parts. I'm going to divide them into 2 equal parts, but the second one I'm going to divide it into 4 equal parts. So here we go. Let's assume that they are equal. And then what I'm going to do is I'm going to shade this part over here. So I'm going to shade half of it and this as well. Now if you look at this part, they're both equal. The shaded parts are the same. There's no difference. They're equal in size. But when I'm writing them as a fraction, they'll be different, because if I'm writing this as a fraction, I would write this as 1 over 2. So, and this would be 2 over 4. Because this is 2 quarters and that is a half. But if I look at the amount, it's the same parts that I've shaded. So this is what is actually equivalent fractions. They have the same amount, but they're shown using different values, a half and a 2 quarter. So this can also be figured out in a different way, where you multiply the numerator and the denominator by the same value. So if I talk about 1, how did this 1 become a 2? 1 is multiplied by 2 to get 2, and 2 is multiplied by 2 again to get 4. So we are multiplying or dividing by the same digit or the same number to get another equivalent fractions. So that's exactly what has happened over here, 1 over 4 or 1 quarter, they've multiplied by 3. So 4 times 3 is 12, 1 times 3 is 3. So 1 quarter and 3/12 is exactly the same. They are equivalent fractions, but they're shown using different numbers there. So that's like the third part of it, and the fourth part of it is write the fractions in each of the following parts in ascending order. Remember, ascending is like going up the hill. So ascending, you're going up. So that's from smallest to largest. You go from a small part of, you go from the bottom to top. So that's what ascending means, small to larger. Now when you look at these numbers here, the numerators are the same, 1 1 1 and 2 2 2. So 1/7, 1/3, 1/10, 1 2, 1 or half. So let's use some practical understanding there. If a cake is cut into 10 pieces and I get 1 of them, and if another cake of the same size is cut into 2 pieces and I get 1 of them, who gets the larger piece? Which one is the larger? Definitely if I cut them into 2 pieces and I get 1 out of them, just 2 pieces, same cake cut into 2 pieces, and 1 piece if I get, I'm definitely getting a larger portion than 1/10. So whenever the numerators, here the numerators are same, we look at the denominator. Smaller the denominator, the larger the fraction there. So we can figure that out that way. And when it comes to different denominators, if we can't find them, we need to find the LCM of 3, 6, 2 and 4. We need to make them equivalent fractions. Like 3, 6, 2 and 4, what is the closest, or what is the least common multiple there? So 3, 6, they're all okay. 3 and 6, we know that 6 is the lowest, but 2 and 4, when you can take 6 there, but for 4 you can take only 8. So you have a problem there, because you don't know what exactly the lowest common multiple for that part would be. So you have to find out, to find the LCM, there are different methods. Either you can list out the multiples of 3. So 3, 6, 9, 12, 15. I'm going to list out a few. And then for 6, you have 6, 12, 18 and so forth. And then when it comes, I think I might need a little bit more there, so I'm just going to list a few more. And when when it comes to 2, I can write like, 2 you still know if you want to write it down, 2, 4, 6, 8, 10, and it goes on. And then when it comes to 4, you have 4, 8, 12, 16, 20, and 24, and then it goes on there as well. So you need to figure out like, what exactly can I take over here to get to the closest or the least common multiple there. So like if you look at these numbers over here, like you have 3, 6, 9, 12, 15, 18, 6, 12, 18, 24. So if you look at them, like I'll just add the 12 here as well, 12, 14, 16, and so forth. So if you look at all 4 of them, they have a number that is common to all of them. So if you look 12, 12, and then we have 12 again, 12 again. So this 12 is common. So least common multiple. That's the lowest one that you can find. If you look at 6, which is the lowest here, but you have 6 and 6 in these 3, but you don't have it in the 4. So you can't take that out. So you take 12 as the least common multiple. That's one way that you can apply, or the other way that you can find the least common multiple is by doing the division method as well. So you can write the numbers down 3, 6, 2, and 4, and then do like the division method. You can write 3, 6, 2, and 4, and I can divide this by 2. So you can continue this and still get the answer 12 as well. So these are like, this is the way you find the lowest common multiple. And then now that you know that the denominator needs to be 12, what next? What's your next step? You find the equivalent fractions. You find the equivalent fractions like 2/3. How would you write them with the denominator 12? So denominator 12 is 3 times 4. So 2 times 4 is 8 over 12. So your first fraction has changed to 8 over 12. And then if you look at the second fraction, it's 5 over 6. So 6 has to become a 12. Denominator is always 12 in this case. So it's multiplied by 2. So 5 times 2 is 10. So that becomes 10 over 12. And next is a half. So 2 times 6 is 12. So 1 times 6 would give me 6 over 12. And last not like, the least part, 3/4. 4 times 3 is 12. So 3 times 3 is 9. So 9 over 12. So now I've got 8 over 12, 10 over 12, 6 over 12, and 9 over 12. So if I need to put them in ascending order, the smallest out of them, denominators are the same, so you just compare the numerators. So smallest of them is like 6 over 12, which is a half. So then it's 8 over 12, which is going to be 2/3. And then it's 9 over 12, which is 3/4. And finally 10 over 12, which is a half. 10 over 12, which is 5 over 6. So that's how we can put them in ascending order when you're writing the fractions. So I hope that part was clear as well. Like these are the basic things about fractions. And next, this part is like where you have to read the question carefully and answer. If 3/4 of a tank which was completely filled with water was used by a household for its needs on a certain day, what fractions of the tank still held water by the end of the day? So a whole tank, 3/4 is used up. Like it's think of it as, you had a chocolate bar and you ate 3/4. It had 4 pieces, you ate 3 pieces, 1 piece remains out of the 4. So as a fraction, if you're writing, you're going to write it as 1 over 4. Likewise, 3/4 of the tank is used up, so 1/4 remains. So that's just like, pretty much it about the fractions. And when it comes to simplifying here, we need to we need to recall that we have to apply the BODMAS rulings here. So when you're adding adding fractions with the same denominator, there's no problem. You just add the numerators and you're good with the answer. Different denominators, find the LCM like the previous one. But when you find the LCM, find the equivalent fractions and then add the numerators and keep it as it is. So when you have off, literally off is multiplication. And don't forget that you have to apply the BODMAS method, the bracket of division, multiplication, addition, and subtraction. So whatever is in the bracket will get simplified first before you move to anything else. And another another important thing that I wanted to show is when you have division and fractions, what exactly happens. So 3/4 divided by a half. So when you're doing the when you're simplifying this particular part, 3/4 remains as it is. The division becomes a multiplication, and 1 over 2 becomes 2 over 1. You don't have this as 1 over 2 anymore, 2 over 1. And when you're multiplying fractions, you multiply the numerator by the numerator and the denominator by the denominator, and then you can simplify it. So 3 times 2 is 6, and 4 times 1 is 4. So answer would be 6 over 4. Since both of them are divisible by 2, we can simplify and give the answer as 3 over 2 if needed. So that's like, oh, sorry, 3 over 2. So that's about, like, simplifying, adding, subtracting, multiplying, dividing fractions, and how to work them out. So do work out the revision questions, this review exercise. This is something that you've been learning from grade 7, 8 and 9, and they're just revising this part before we move into the grade 10 mathematics or grade 10 fractions or the O-level fraction questions itself. So now, like, let's move into the next part, like the 3.1 parts there, where they're going to apply, or applications of fractions. They're going to apply fractions into real life examples itself. So if you look at this example 1, they're talking about a Kurakang flour, or a flour that they're preparing, which consists of Kurakang flour and wheat flour. They're going to put the two flours together. So when it comes to this part, 2/5, let's read out the question. 2/5 of a mixture of flour prepared to make a certain type of food consists of Kurakang flour, while the remaining portion consists of wheat flour. So if 2/5 is Kurakang, remaining would be 3/5. So 3/5 is wheat flour. And then they're talking about a cook who wishes to prepare 50 kilograms of this mixture to make the food item. Now, they've shown us a bar model again, like, this is once again to show a visual understanding of what exactly do they mean. So they have shown a bar model. They've divided it into 5 equal parts, because we are referring to 5 parts here, 2/5. So 5 parts, out of which 2 parts are for Kurakang and the remaining 3 parts are for the wheat flour. Now the total is 50 kilograms, the mixture of both. So basically, if this 5 parts is equal to 50 kilogram, we need to find how much 1 part is equal to. So to find that, we divide the 50 by 5. Now when I divide 50 by 5, I get that 1 part is equal to 10 kilograms. So 1 part is equal to 10 kilograms means 2 parts, which is Kurakang, is 10 plus 10, 20 parts. And then the remaining, if 10, 10, 10 is 30, 30 for wheat flour. So that's exactly, like, that's the understanding that we have here, how we can figure it out, how much is equal to. Or basically, you know that if I'm writing this down, like, using a calculational method, you know that 5 parts is equal to 50 kilograms. And you need to find how much 1 part is equal to. So 1 part is equal to 50 divided by 5, which gives me 10 kilograms. And then now we know that Kurakang had 2 parts. So to find the 2 parts, I'm going to multiply 10 by 2, which gave me the answer 20 kilograms. So that's like how we can work these questions out. So like I told initially, to work out the fraction questions, it's basically to understand the question clearly. It's once you understand the question, it becomes easy for us to apply this, and because we know this part, we really do understand what they're trying to say. But once we read the question, we might get confused, or we might lose track of what needs to be done. So let's look at another example. This lesson I'm going to do it in detail, or like try to do a lot of questions as possible, because like I told you, this one chapter, if you're really thorough with, you can score 10 marks, like a confirmed 10 marks for the paper. If not for 10 marks, even 8 marks at least you can score. So let's give it our best shot there to understand this lesson itself. Let's look at example 2. So it takes 12 minutes to fill 1/4 of a certain tank using a pipe through which water flows at a uniform rate. Find the time it takes to fill the whole tank with water using this pipe. So remember, like, the important thing over here is it takes 12 minutes to fill 1/4 of a certain tank. So if I am having, if I'm having one tank over here, if this is my tank and this is divided into 4 equal parts, one part of it takes 12 minutes to fill. So here, since they've given us that one part takes 12 minutes, we know that each part would take 12. So 12 we need to find for 4 parts. So we can multiply 12 by 4 and get the answer there as 48 minutes. So this is like the the visual understanding, or the diagram understanding there, how we can find it out. 12, 12, 12. So you can add them. 12 plus 12, 24, 24 plus 12, 36, 36 plus 12, 48. Even that way you would get the same answer, 48 minutes. So like the major point here is about it's at a uniform rate. There's no high or low, it's the same rate that it's following. So that's why we can say that this would be our final answer there. Looking at example 3, let me clear the screen before we move. Selva can travel 3/5 of the distance from his home to the school by bus. This distance is 12 kilometers. Now, the thing that you've got to understand is that 3/5 is equal to 12 kilometers. So basically, if I draw this in a bar model, I need to put 5 parts because the denominator is 5. It's divided into 5 parts. We're talking about 3/5. I divide them and I put them into 5 parts, but 3 parts of it is equal to 12 kilometers. So you can see that they've shown us that 3 parts is equal to 12 kilometers. Now to figure out what is 1 part equal to, I can divide this 12 by 3 because 3 parts equals 12. So 1 part equals 12 divided by 3, which is 4 kilometers. So 1/5 or 1 part out of 5 is equal to 4 kilometers. What do we have to find? The distance from his home to the school. So the distance is actually, the total distance is 5/5 because though he travels 3/5 by bus, the remaining 2/5 is either traveled by walk. There, we are not sure, but that definitely is there in the distance there. So we multiply 4 by 5 this time. Now why 5? Because the total distance is what they are asking. So 4 times 5 is 20 kilometers. So that's how they get the answer. I mean, you get the answer. The total distance is 20 kilometers. So if you look at the fractions questions, they are pretty simple, very straightforward over here. And it's just about understanding what are they asking for, and you can figure it out. So the last example before we go to the exercise 3.1 itself. A tank was filled with water up to 4/5 of its capacity. After consuming 350 liters of this amount, the quantity of water remaining filled 1/3 of the tank. Now let's get a clear picture of the question before we answer the question. There is a tank, they've not filled it to the full, they've filled only 4/5, and from that 4/5 they consume 350 liters, and after they consume that 350 liters, the remaining water in the tank is 1/3. So if I have to show that as you know, to get a better understanding, it's 4/5. From that you subtract 350 liters. So we have fractions and liters together in this, just to show you, just to give you an understanding. And now we have 1/3 of the fraction remaining. So basically the amount that 350 liters over here is equal, if I have to show that as a fraction, that is from 4/5 you subtract 1/3. From 4/5 if I subtract 1/3, I get the fraction that shows how much water has been used. Because initially I had 4/5. It's like saying initially you had 1 whole cake and now you've eaten half and there's half remaining. So how do you find how much, the fraction that you ate was 1 minus a half. So likewise, to figure out how much water was used, you can find 4/5. From 4/5 you subtract 1/3. So like I told you, when you are subtracting fractions with different denominators, you need to find the LCM. So 5 and 3 LCM is 15. So 5 times 3 is 15. So 4 times 3. 4 times 3 is 12. 3 times 5 is 15. So 1 times 5. You have to find the equivalent fractions there. So 4/5 will be written as 12/15. 1/3 as 5/15. But since the denominator is same, there's no problem with it. We leave it as 1. As one denominator 15. And then we subtract the numerators. So 12 minus 5 is 7/15. Now basically this 7/15 is the water that, the quantity of water that was used, right? So we know that consumption or used water was 350 liters. So 7/15 is what is equal to 350 liters. This is equal to this. So which means if that tank was divided into 15 parts, 7 parts of it would be equal to 350 liters. So now we need to figure out the capacity of the tank. So we know that 7 parts is equal to 350 liters. But what are they asking us to find? The entire capacity, which is 15 parts in total. This is our question. We don't know how much the 15 parts equals to. But to find that, we can do this. We can find 1 part, which is equal to 350 divided by 7. So I can divide 350 by 7, which is equal to 50 liters. So 1 part is equal to 50 liters. So to find 15 parts, I can multiply 50 liters by 15 there. So when I multiply 50 by 10, I get 500, and then by 5 is 250, so the answer would be 750 liters. So the capacity of this entire tank is 750 liters. So I hope this question was clear as well. Like if you have any questions, like I said, do email them to me, and I'll be there. I'll readily help you out with them. So based on that, we have this exercise over here where they've given us a few questions, and they're asking us to find the fractions sometimes like the capacity. So you just have to read the questions carefully and answer them. Moving to like the last part of the of fractions itself, that is the further application of fractions. Here there's a little bit of a twist. Okay, so there's one particular word that comes into this question which does the entire twist to the fraction questions itself. So we will look at an example to get a better understanding here. Now let's listen carefully and understand the question. Like I told you, fractions is about understanding the question even before you apply maths here. So it says, from the money that Raj received from his father, he spent 2/3 on books and 1/4 of the remaining. Like I told you, there's one word that does the twist to the question itself. So the twist that is happening is by this word remaining amount. Now what exactly do we mean by this remaining amount is another question that comes in there. So let me just highlight that this is a really important word, because it comes in many questions. So maybe when we are doing papers and when we pick fraction questions itself, you'll figure out how important this remaining amount or remaining word is. Now let's get, like I told you, let's get an understanding on the question itself. He spent 2/3 on books. So I'm going to write that here. He spent on books 2/3 of a fraction. So since I can't put the fraction, I'm just going to put it as 2/3 there. And then 1/4 of the remaining amount. Before I find 1/4, before I write 1/4, I have to figure out what the remaining amount was. So after he spent 2/3 on books, his remaining amount was 1/3. Because let's say I had a chocolate, I ate 2/3 of it, or it's divided into 3 parts. I ate 2 parts, I have 1 part remaining. So if I'm showing that as a diagram or visualizing what I mean, let's think of it this way. This is my diagram. I'm dividing this into 3 parts, 3 equal parts. Yeah. So 2/3. Now this particular part has been used up for the books. 2/3 is used up for books. So this 1/3 is what I have remaining now. Now what they mean is 1/4 of the remaining amount on travel expenses. This remaining 1/3 is divided into 4 parts now. So they're dividing this into 4 equal parts. So I'm going to divide this. Let me get a different color to give you a better understanding. So yeah, I'm going to divide this into 4 equal parts. So this needs to be like they're equal parts, not unequal ones. So yeah. So that amount, 1/4 of the remaining 1/4 of 1/3, that is basically this, just one of these parts is used for travel expenses. So this blue line is for books and this part is for travel. So now how do I show this using the fractions itself? So for travel, it's 1/4 of 1/3. So when you say 1/4 of 1/3, you basically mean that you're multiplying 1/4 by 1/3, because of is multiplication in this case. So 1/4 multiplied by 1/3, which gives me the answer. 1 times 1 is 1, 4 times 3 is 12, so 1/12. That's the answer that I get there. So I'm going to add in the fraction bars to get a clear understanding. So 1/12 is used for traveling there. Now remember, we've not read the question yet, but we have put up a block there, put up and to understand the question, we have written down whatever we've understood, we've written down. While you do that, you're actually figuring out the answer even before you read the question. that's how fractions work, right? Now the next part that they're telling, after that he had a balance of rupees 500. So basically the balance 500 is from this particular part here. These three parts are the ones that are balanced, and this balance is equal to 500 rupees. Right? So now how much is this fraction is another question that comes up. So first, next what we can do is let's read what they're saying. What fraction of the amount Raj received from his father was remaining after buying the books? So like I told you, here we go, our first answer is done. Even before we came to the question, we figured out what the answers were. Second question, what fraction of the amount the father gave did he spend on traveling? Even that is done. We figured the second question's answer as well, because this is how much he spent for traveling, 1/12. Now comes the next part, find the amount he obtained from his father. So to do this, we need to figure out how much did he spend on books and how much did he spend on traveling. So for that, now this is what his father gave. Now the amount that the father gave is going to be written as A, which was spent on books, spent on traveling, and we have 500 rupees remaining. So these three amounts added together is what the father gave. So to get that, we need to figure out the fractions, right? The fraction that was spent on the books and the traveling. So when you talk about the books and traveling, for books it was 2/3, and for traveling it was 1/12 as a fraction. So this Raj has spent 2/3 and 1/12. Now to get the fraction here, we need to add the denominators have to be 12. The LCM of 3 and 12 is 12 itself. So 3 times 4. Okay, let me put this first and then we'll go for it. Yes, so the denominator should be 12. So 3 times 4 is 12. So if I multiply this by 4, I need to multiply this by 4 as well. So 2 times 4 is 8. Here there is no change because the denominator is 12 already. So 8 plus 1 is 9/12. Now what is 9/12? The amount that has been spent for books and for traveling. So the remaining amount, if 9 parts out of 12 parts are gone, we have 3 parts remaining. So basically, like I showed you initially, these 3 parts, but this time out of a 12. So 3 out of 12 is what is remaining, and which is equal to 500 rupees. So we can write it as 3/12 parts is equal to 500 rupees. So to find one part, I need to divide 500 by 3. But since if I divide this, I might get a question, I might get an answer in decimals. I'm not going to divide it, I'm going to leave as it is, 500 divided by 3 or 500/3. And what is the question that they're asking? Find the total amount he obtained. That is the entire 12 parts is what we need to find. So to get the 12 parts answer, we have to do 500/3 multiplied by 12. So this is what we need to do. Now how can we simplify this? So like I told you initially, let me first move the screen down. Okay, I think that's not visible to you, so I'm just going to write that back again here. So 1 part equals 500/3, and 12 parts is equal to 500/3 multiplied by 12. So this would come here as 3. So 500/3. Now I'm going to show you how we can simplify this. So to simplify this, we can divide this 12 and 3. Now if I go to divide 500 by 3, I will get a decimal answer, and then I multiply a decimal. It's quite complicated there. So what I can do is I know that 3 and 12 can be divided by 3 itself. So I'll go with that step. So 3 times 1 is 3. 3 times 4 is 12. So 500 times 4, 500 multiplied by 4 would give me the answer 2000. So the answer here is 2000. How much did the father give? The father gave 2000 rupees to Raj. So that's how you can figure it out, and here we go. They've got the questions. They've got the same answer there as well. So this is how fractions is applied. There can be a little bit, like I told you, it's only to understand the question there, and then we are pretty good to go. We write what we've understood, we found the answers to the questions there as well. So based on this understanding, you have a few questions over here as well. Do give them a try, and then, like, if we will definitely do a few fraction questions, a few past paper questions in the upcoming videos as well, so that you have a clear idea and an understanding, and you get the confirmed 10 mark for your paper. So thank you very much for joining in and listening to me carefully there. So see you until next time. Don't forget to share, like, and subscribe. So thank you very much. Have a nice day. Bye bye.